to your next challenge entitled Smooth Sentences. Carlos is a huge fan of something he calls smooth sentences. A smooth sentence is one where the last letter of each word is identical to the first letter of the following word. To illustrate, the following would be a smooth sentence. Carlos swam masterfully. Since Carlos ends with an S and swam begins with an S, and swam ends with an M and masterfully begins with an M. So you see how they kind of chain together there. That's the idea. Feel free to go through these examples. Note that the middle one is false. You've got this one ending in E and starting with an I. Even if they may sound somewhat similar, that's not good enough. We're matching strictly against letters. So, I think we're good there. Let's head over to code. Please pause the video and implement this and begin again when you're ready. So first things first, I'm going to chop this sentence into a collection of words. So let's call it words equals sentence. Remember split we've used before? And I'll pass it a character, and one of the overloads is supported there, and I'll just do it by space. Now keep in mind this wouldn't catch cases, or I don't think it would, where you separated words with tabs or other kinds of white space characters. So if you want to account for all of that, feel free. So now that we have a collection of words, I'm going to iterate over them, starting from the beginning. And note here, I'm going to actually come up one short, because if you consider the final word, there's no subsequent word to compare against. So at that point, we're good. We don't need to process that final word. Okay, so at any point, let's grab, we can call it current word, would be words I, and well, I'll leave it like this for now, and we'll talk about a problem here later. Current word, and then we'll say next word equals words I plus 1. That would grab the next word, right? And then we can say if current word, I'm going to take the final character of that, right? And we know we have this substring method to do that. And so what we can say is current word dot length minus 1 will go to the final character, right? That'll put us, so we only have one character left. And our second argument says how many letters to take. There's only one letter to take at the end, so I'm providing 1 there. So if it's not equal to next word substring, what do you think would go here? We want the first letter. Index 0 would be the first letter, and only grab one character, right? So if that's the case, then we have a problem, right? That means this is not a smooth sentence. The letters are different. So we'll say return false. And then provided you survive here, you never meet this condition. By the time you've processed all of the words except for the last one, which is unnecessary, we can say to return true that everything matched up. So there is a slight problem here, but let's give it a run. This should mostly be okay. And look at that. You heard the sad music. We got a bunch of check marks. What happened? Failed. Rita asks Sam mean-numbered dilemmas. That looks like it should be true, right? Why did we get false? Look at it closely. Pause the video if you like. And the answer being is we got gigged here, didn't we? Remember, from the computer standpoint, lowercase s is different than uppercase s, right? So we need to account for that. And one way you can do that is to convert these to lowercase then everything will be lowercase, and that sort of takes case out of the equation. I suspect if we rerun with this now, we should be okay. And there we go. We're good on that test now. Yep. So for the comparison itself, this would be lowercase SAM, and that's fine. We didn't change their sentence at all. We just did that for our own work, and that's fine. So, yeah. Hopefully you came up with a good solution. If you did something with link, something concise with link, that would be really cool to see too. Feel free to share that. Otherwise, drop your questions below, and we'll see you in the next video. Thanks for watching.